I'm Michael Wellman. I'm the Lynn A. Conway Collegiate Professor of Computer Science and Engineering at the University of Michigan. I lead the Strategic Reasoning Group. In my research group, we study strategic environments. What that means is we consider agents that have to make decisions in environments where there's other agents. This is called a multi-agent system, and this poses the interesting question of how collections of intelligent agents might behave differently than when you just consider the problem from a perspective of an individual agent. In my group, we have historically taken a kind of economic perspective, inspiration from the field of economics on how to think about multi-agent systems. We use a lot of the tools of economics, including especially game theory, but also the study of markets and the study of decentralized behavior, the study of rational decision making. In my group, we've been building techniques to try to understand multi-agent systems, both from the perspective of an individual agent who may be part of a multi-agent system, maybe playing a game, or from the perspective of someone who may want to analyze a multi-agent system to understand it from an outside perspective, may want to design an environment so that a multi-agent system performs well, that it achieves certain objectives. In the group, we build techniques for strategic reasoning, for understanding multi-agent systems formally. We frame these as a game. That means that we use the tools of game theory, which just really asks the question about what happens when you have some agents who behave rationally or approximately rationally, but yet their decisions depend on what each other's do. So you cannot just look at a problem to say what is the optimal thing for one agent, for one agent's decisions, without thinking about how are the other agents going to react, or how are they going to anticipate what our own decisions are. Often this gets one into a kind of mode of equilibrium thinking, to what happens when the group of rational agents is all thinking about each other, and the game theoretic framework helps us think about that, think about those kinds of situations. Now, traditional game theory relies on mathematical modeling of a multi-agent environment, and the typical techniques, analytic techniques from game theory, say as used in economics, have a problem of dealing with very complex environments. So a really key idea that has been pursued in my research group is an approach we call empirical game theoretic analysis, where we embrace techniques like agent-based simulation and machine learning and statistical analysis to try to use these empirical methods to understand game situations. In an agent-based simulation, we can actually represent a very complex environment. For example, a market, for a scenario in electronic commerce, or for a scenario in economic decision making, and simulate it and run through our simulator many different combinations of different agent behaviors, and use the data we get out of that to build a game model. That's been the basic approach of empirical game theoretic analysis that we've been developing in our group. Lately, it has been used in tandem with modern AI reinforcement learning methods, especially deep reinforcement learning. That has turned out to be a really powerful tool for exploring a vast space of possible strategies that agents can pursue. And in fact, this kind of approach of using deep reinforcement learning in combination with game theory has become increasingly popular in some areas of AI research. In addition to building the general techniques for strategic reasoning, in my group we often focus on driving applications, and especially applications that help us understand what are the economic implications, or what are the broader implications of bringing AI into real-world situations. We've been focusing a lot on economic domains, and especially over the last 15 years, in domains in the area of finance. We want to understand what are the implications of AI for financial markets and the financial system. There are a couple of reasons for focusing on finance. One is simply because financial markets and finance more broadly is one of the leading areas where AI is already widely deployed. AI for making decisions about credit, or AI for algorithmic trading in financial markets. Agents in financial markets behave autonomously because they need to respond to market information at very rapid speed, faster than human reaction times. And so because of that, it's been one of the first areas where we've really seen autonomous agents performing important tasks and high-stakes tasks in the real world. Therefore, it makes for a great case study in understanding the implications of autonomous agents, advanced AI, and how to design environments so that AI is effective and leads to better outcomes. So over the recent years, my group has been trying to understand what are the implications of AI on financial markets and the financial system. Another reason that this is important is because, as we've seen in recent memory, when the financial system does not work very well, the economy can suffer dramatic effects. And could AI make the financial system perform better? Does it impose additional risks? Does it change who are the winners and losers in our financial system? These are really important questions to understand, and therefore, having some public research in this area is quite important. These days, when everyone is trying to understand how is AI going to affect society and the economy, there's another reason that looking at the financial system is a pretty interesting case study. And that is because the financial system is highly regulated. And if we want to understand how to regulate AI in a lot of domains, you might want to look to one domain that already has a lot of regulatory infrastructure. Firms that operate in financial markets already understand that they need to follow the rules, and they're used to complying with regulations. So how well we do at regulating AI in financial markets may shed some light into how we can or cannot regulate AI in other domains. Well, this is a really exciting time to be an AI researcher. I've been myself in the field of AI for about 40 years, since I started graduate school. And of course, AI has always been a really scientifically interesting and exciting area. But now, when we really see dramatic new capabilities that are surprising people and raising all kinds of questions about how far can it go, being part of that is especially exciting. And in particular, the new questions that come up regarding how can we anticipate the implications of AI in important areas, how can we build tools to help evaluate AI for safety, for questions of risk, for trying to understand performance. There's a whole host of new technical questions that arise because the development of the technology is in some respects outpacing our ability to understand it and predict it. That is itself a concern, but it's also a great opportunity to try to advance the field of understanding AI. When I first came to Michigan in the 1990s, the World Wide Web was brand new, and the importance of social computing and understanding interactions of a lot of different agents with AI was really just emerging as a major concern. Our group was one of the first ones that embraced the economic perspective and the tools from economics to understand this. Now, economics and computer science has become an established field. I'm not taking credit for that, but having taken a careful look at that perspective early on really helped us get to be at the leading edge of some of the early developments in electronic commerce and in bringing in game theoretic tools for the study of strategic environments. To find more about my group, go to strategicreasoning.org.